The last graph we're going to make for quantitative variables is called a histogram. And the first thing we want to do in a histogram is we want to count the number of data points. So in this table of heights of students, there are 22 data points. I also want to point out that heights of students we know is going to be a quantitative variable, as we already know, and is going to be continuous. So this is continuous data. The next thing we want to do is we want to determine the number of classes. In a histogram, that means the number of bars that we're going to be using. There are many different ways to determine the number of classes. There's no firm rule for this, which means that two different people could create two valid different histograms. As a guideline, we're going to take the square root of n. So in this case, we have the square root of 22, which is approximately 4.69, and we're going to round that up to 5 bins. So our number line is going to be divided into 5 equal pieces. So the way we figure out how large our interval is going to be is we take the range of data. The largest value in this data table is 73, the smallest is 44, and we're going to divide that into 5 equal bins. That comes out to 5.8, which we're going to round up to 6. Even if we divided and our quotient was 5, we would still round it up to the next whole number. So the next thing we want to do is we want to create a frequency table. A frequency table lists our interval and the number of data points that fall within this interval, which is the frequency. So starting with our smallest value of 44, we're going to add our interval width. So 44 plus 6 is 50. Now notice that 44 is included in this interval, while 50 is not. 50 actually is going to get included in the next interval. So we know that our maximum value is 73, and as you can see, our last interval does include 73. And we have 1, 2, 3, 4, 5 intervals, which is going to make 5 bins. So again, it is helpful to go back and put the data in the calculator. That way you can sort it, and it'll make it easier that way. So I'm going to do that right now. Alright, so in list 1 we have one number within the interval 44 to 50. Then in the next interval we have 2 data points that fall within 50 to 56. Next we have 1, 2, 3, 4, 5, 6, 7 data points that fall within this interval. Then we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 4. We should have 22 data points altogether. So 1 plus 2 is 3, then we have 10, 18, 22, so that works out. Next we're going to create a first quadrant graph. On the x-axis we're going to have our height. And on our y-axis, we're going to have the frequency. You can see from our frequency table that the largest value we have is 8. So each bar is going to represent the frequency, how many data points fall within that interval. So for 44 to 50, we have 1 data point. Then we have 2. Then we have 7. Then we have 8. And finally 4. Notice how this is different from a bar chart. In a histogram, the bars are touching. And we know that looking at it, this value of 50 does not actually belong in the first bin, it actually belongs in the second bin. So any value that is in the back is actually in the next bar behind. So again, this was for continuous data. Here in our next chart, we have a number of absences in the third quarter, which is going to be discrete data. The idea for a frequency table still stands, it's just slightly different. So in the calculator, I've entered all of these frequencies and I'm going to sort them. So the number of frequencies, or the number of absences, go from 0 all the way up to 8. So there are 3 absences of 0, 3 of 1, 2 2s, 4 3s, 6 4s, 'This is slightly different because our x-axis, we're going to actually use the midpoint instead of the actual value as the end of each bar. So again, we're making a first quadrant graph. Number of absences is our x-axis. Frequency is our y-axis. We see that we have 0, 1. And our largest frequency here is 6. So with discrete data, we want to use the marker as our midpoint. So to show that there are 3 absences that are at 0, we put it like so. This would read as 0 absences. 1 absence. So when we read this histogram, we can see that the midpoint is actually the number that is in that bar. So we have 3 zeros, we have 3 1s, we have 2 2s. We would do this for midpoints when we have discrete data.